Hey guys, in the first example problem, what we are doing is we are given that a football field is 120 yards long, because we're including the end zones, and we are asked to convert the length of a football field to meters. So I am representing the length of a football field with the symbol L. L is equal to the length of a football field, and that is equal to 120 yards. I'm just choosing L because it would be very tedious to write length of a football field over and over a lot on this board. We are also given that 1 meter is equal to 1.094 yards. So this conversion, if you are comfortable with math and science, this conversion could be very quick, but I want to go slow through this for the purpose of pointing a few subtleties out that we often just skip over. So, number one, whenever we have an equal sign in an equation or anywhere, we could kind of think of that as designating whatever is written on the left of the equal sign is the same as whatever is written on the right of the equal sign, no matter how it's written. So L is the length of a football field, 120 yards is the length of a football field. So based on what I have written on the board, 120 yards is this long and L is this long. They are conceptually the same thing. They are equivalent, they are equal. Similarly, 1 meter is about this long and 1.094 yards is about this long. They are the same thing. So I am going to write the length of a football field, L is equal to 120 yards. We also learned from grade school math that whenever you multiply something by the number 1, you get that something back. So multiplying by 1 does not change whatever you're multiplying by. So I'm going to multiply the length of a football field by the number 1. It is not immediately obvious why we would just multiply by the number 1. What's the usefulness of this? We'll see shortly. I also said in the PowerPoint slides that anything divided by itself is ultimately equal to the number 1, and doing a unit conversion is fundamentally just multiplying by the number 1. So what do I mean by that first statement? Well, we also learned from grade school math that whenever you divide something by itself, or write it as a over a, like a fraction, that is always equal to the number 1. Now, I'm being ambiguous right now. What is a in this equation? Well, I'm not telling. But one more concrete example is I could write 4 over 4 is equal to the number 1. I'm dividing something by itself. That gives me 1. What if I want to write this a bit differently? What if I want to write 2 plus 2 divided by 4 is equal to 1? Well, 2 plus 2 is the same thing as 4, and 4 is right there. So what I wrote on the top and the bottom are the same thing. This is kind of why I was saying the equal sign implies whatever's on the left side is the same as whatever's on the right side. I am dividing this by itself, so I could still write this as the number 1. Now, I could write the number 1 in a much more abstract way. So let's say your university divided by the home of the Purple Eagles. What is this equal to? Well, your university is Niagara University. The home of the Purple Eagles is Niagara University. And I am taking something and dividing it by itself. And we said before, anytime you divide something by itself, it is automatically equal to the number 1. So I wrote 1 in a very abstract way here, but this term is still equal to the number 1. Okay, so why did I decide to write the number 1 in this very abstract way? We could divide numbers, but here it's kind of almost like I'm taking an idea and dividing it by that same idea. or I'm taking some object and dividing it by itself. So we said that the concept of 1 meter is the same as the concept of 1.094 yards. So if I divide 1 meter by 1.094 yards, that also will be equal to the number 1. So I could write 1 is equal to 1 meter divided by 1.094 yards. And this is the number 1 that I'm going to plug in right up here. So I could write the length of a football field as being equal to 120 yards times 1 meter over 1.094 yards. And now I am going to multiply this through. Whenever we multiply through things using a unit conversion, we will keep the units, the meters, the yards, if we're multiplying distances, or if we're, for example, multiplying time, we would keep seconds or hours or microcenturies or whatever standard of time we're working with. So I would write this as L is equal to 120 times yards times 1 times meters divided by 1.094 times yards. Now I very explicitly gave every term here in its own set of parentheses just so I can point something out. Like I said at the beginning, this example of a unit conversion is way in depth just to point out some subtleties. One thing with math, whenever you have something upstairs and that same thing downstairs, they automatically cancel. So I could say yards will cancel because it is upstairs and downstairs. 120 times 1, that gives me 120. So I then get L is equal to 120 times 1 times meter over 1.094. So I could write this as 120 over 1.094, and I'll just bring meters outside the fraction. Whatever I am always allowed to bring something upstairs in a fraction out front. I'm not breaking any rules by doing that. I brought the unit of meters out here just so it could kind of be by itself now. And then 120 divided by 1.094. I put that number in a calculator and I will get some weird decimal out. And I'll get the number of 109.6 meters. So I find the length of a football field is equal to 109.6 meter. Okay, we're done with this. Now there are two things I want to point out that if you're not very comfortable with math, like I said, it is my intention that this course is invigorating and interesting for you. I don't want you to be scared away with math. So we chose to write the number 1 like this. Why did we choose it like this? Because I could just as well have written 1 is equal to 1.094 yards over 1 meter. And this is also true because I am taking something and dividing it by itself. Why did I choose this instead? One thing is, I know that at the end of the day, I want my final answer to be in meters. So if my final answer has yards anywhere in it, I did something wrong, or I was not efficient with what I wanted to do. Remember that if I have the same thing upstairs and downstairs, those things will cancel. So I want to get rid of the yards and only have meters left over. So at this stage in the problem, I look here, I see, well, yards is currently upstairs. And so in order to get it to cancel, I have to have yards downstairs when I take this number 1 and write it in this creative form. I want yards to be downstairs so it could then cancel out here and here. So that's why I know I want to work with this guy and not that one. Point number 2, what about multiplying by fractions? So when I multiply by fractions, in general, if I take a fraction a over b and I multiply that by c over d, when I multiply the fractions, this is just equal to ac over bd. So here I had 120 yards times 1 meter. That's like my A and my C. I have a 1.094 yards down there. This 120 yards, I could think of as looking like 120 yards over the number 1. And now this is like my A and my C. That gives me my 120 in yards and 1 in meter. And my B and my D, that's like my 1 and my 1.094 yards. Here's the 1 here is implied, and my D there. The second thing I want to point out is another way we could think about it. The way I looked at this was, I know I want to cancel the yards upstairs, so I need a yards downstairs. But there's another way we could think about how to do this conversion. Think about the distance from New York to LA. Now, that distance is 3,000 miles, give or take. So it's 3,000 miles from New York to LA. The number describing the distance from New York to LA in inches, will that number be bigger than 3,000 or smaller than 3,000? And you say, well, okay, we have New York to LA, and this is 3,000 miles. But you know an inch is much shorter than a mile. So the number of inches from New York to LA will be much bigger than 3,000. I expect if I were to write the distance from New York to LA, that number should be huge, followed by the word inches. So this will be something that is huge in inches. Why did I bring that up? Well, 1 meter is bigger than 1 yard by a little bit. Therefore, by a similar line of reasoning, I expect the length of a football field in meters to be a smaller number than the length of a football field in yards. It's like saying if I gave you the distance from New York to LA in inches, or let's say the distance from New York to Miami in inches, and then I ask you to convert that to miles, I'm going to give you a giant number because it's a lot of inches from New York to Miami. And then you will do a conversion. You expect the number of miles to be less than the number of inches. At the end of the day, both of those lengths are the same thing though. So that is the end of this first example problem, and I will continue with more soon.